Hi, good morning, everyone. Thanks for joining me this morning. Still a few people are walking in, but just let's get started to get back on schedule. I'm actually wondering whether it's a good idea to actually do this talk after this morning's second keynote, because we're all going to die anyways, but let's give it a try. Today I want to talk about microservices and the things we learned at Atlassian building them. And you always have, when you start with a new language or a new technology, you always have that moment a few months later, maybe even a year, when you think, hey, if I only knew that before when I get started, then I didn't make all those mistakes and don't want to rewrite all those things again. And that's what we're going to do this morning. And to get you started, I have a little challenge for you. I'm going to talk about 5 things, and I want you to take at least one thing home. So not all 5, just 1 out of 5. So I think that's only 20%, so that should be manageable. And it would be great if you can have some questions at the end as well, because they gave me a nice little gadget. It's actually a microphone in a box I can throw in the audience, which is pretty cool. I'm keen trying that one out. So save your questions to the end. A little bit about myself. This is my Twitter handle. If you have any questions after the conference, just find me online and let me know what you think, or if you have any questions. I'm from the Netherlands, moved to Sydney, Australia 4 years ago, working for Atlassian, and I'm looking after cloud architecture and a deployment pipeline for Confluence Cloud. But it's not about me today, it's about microservices. And whenever you go to a conference, microservices are still a hot topic. Earlier this year, I was talking about monoliths in the conference, and the room was a little bit more empty, actually. So still a few people turned up, but not as many as this. So it must be something fascinating, and we're really keen to figure out, hey, why do we actually want to do microservices? So that's actually because we probably have a problem right now. So to answer the question why microservices are popular, we have to look in the problems we currently have. And if you work on a large and monolithic application, you probably have some issues. I'm not sure how many architects you already had, but this sounds pretty familiar to me. We like to put on layer, and that doesn't give always a great result. So what issues do we have with a monolithic application? First of all, they grow fat. The older they get, the more you add. You get more code, you get more builds, you get more tests, and it becomes harder and harder to actually get your head around. The other one, especially, for example, if you look at Confluence, it's a 14-year-old code base. They age. So you probably will have every technology over the last 14 years in your code base. Whenever a new hype pops up, you think, hey, that's cool, I want to try it. But you don't replace it all, so you have like a mixed bag of technology. And sometimes you have to change something in the code base, you just hit that interesting code path you don't want to touch and nobody wants to touch. Another issue is ownership. If you have a large code base, it becomes harder and harder to define ownership. Who is owning which piece of the software? And there are tactics around it, especially around code organization. But what about having a pager? Who wants to get called at 3 a.m. in the morning if it's not a change you actually did, or it's something you don't know anything about and you have to wake someone else up? And the last one is actually economies of scale. Normally, when you're in a production company, the larger you grow, you get some sort of advantage because you do more things, things get cheaper. However, if you do software, the larger you get, things become harder. And if you have a large team, like let's say you have 100 engineers on one code base, it gets harder and harder to get the same productivity or get the same feature output based on the amount of engineers you have, which is not great. So let's look at a few examples from the Confluence team. Just out of curiosity, who's using Confluence in this room? Oh, quite a few. That's great. I don't answer any Confluence questions. That's for someone else. And this will be the only product placement, so I'm not going to talk a lot about the product itself. So if you look at Confluence, we run around 81,000 build jobs a week. So that's quite a lot. So we need a lot of infrastructure to actually get the things going. And we probably run a lot of jobs that actually doesn't have to do anything with the change, right? So it's quite wasteful. The same with test automation. We have around 32,000 tests. And whoever wrote any automated test, they look good when you start, but over time, they will get flaky, they fail. You change the comment in your code, and they fail, and you say, hey, what just happened? And it's always you, for some reason. The other one is when you have an issue. For example, this is a performance regression we had 2 weeks ago, and we suddenly had a big regression in the server response time. How do you figure out what actually happened? Because you have many, many commits. You maybe bumped a few libraries, so you don't have an idea what's going on. So it takes a lot of time to figure out which commit was causing this issue. And you can add more tests to actually detect it earlier, but it has a cost as well. And I already mentioned this one, and this is like most developers hate. If you have a pager and you get a call at 3 a.m. in the morning and you don't know what happened, or you see the change, and you have to call another developer, and the developer needs another developer. It's really hard to define which part of the organization is responsible in case of an incident. And the time it takes to actually recover from an incident will be longer and longer. But before we go into microservices and the advantages they bring, we should all remember that we're not all web scale, right? Sometimes a solution can be very simple. Just a simple CRUD application just does the job. And if you look at most conferences when you hear about microservices, most of the time it is companies like this, like the Netflix, the Twitter. They have enormous amount of data and traffic. So you always have to realize, is it something I really need, or can I do with something else? And I came across a quote from Dan North, I think a few weeks back, and he kind of said, and it's the responsibility for any engineering team to actually focus on rapid and sustainable flow of value. So if microservices will help you achieving that, then you're probably the right way to go. But if you do microservices because you just think it's cool, or you just heard it at the conference, then you probably have to think twice, because everything you do has a cost attached to it. And we are here to generate value, not to do engineering, or probably both. So what's the promise microservices give? First of all, they're small, and that's a bit of an open door, but I'm not going to discuss like actually code size, or like whether this should be 80 lines of code or 500 lines of code. For me, it's really important that they actually can and be owned by one normal engineering team. If you need 2 engineering teams, you already lose a bit of the value, and you only add cost to it. So that's probably a rough estimate, like how big should it be. And it should be a coherent thing. It should have like a single responsibility. It shouldn't do too many things. The other one is an independent lifecycle, and this is one, and this is really important. We looked earlier at economies of scale. If you have a service, you have an independent lifecycle, and suddenly your team isn't locked in anymore. They can basically say, hey, we own the whole service, we own it end to end from all the way into production, so nothing is holding us back. So we can optimize our workflow the way we work without having any dependency on another team. So there's no finger pointing, so this is great. There will be always dependencies between various teams if they rely on providing a service. However, the team can optimize for their own goals. The third one is like, you optimize for the problem. If you have a monolithic application, you probably already have a tech stack chosen, and that's not always the right thing for the job you're solving. Sometimes it's more CPU bound, or it's more I/O heavy, so you want to make different changes based on that. Also, sometimes a different language is slightly better to solve the issue. I'm not saying you should pick a different language or framework for every service you build, because you want to transfer them between teams as well, but it gives you the opportunity. Last one is replaceability. And if you have a large code base, replacing it will be hard and will be very painful. And it probably doesn't have a lot of value to replace everything. Like you only want to change things if you touch the lot instead of doing all the code base. With services, you can actually say, hey, this is something that causes so much pain. It's a language or a framework we've used. We're not very happy with it, so we replace it. We have done it a few times with Atlassian. We weren't too happy with the choice of a language, so we actually replaced it completely. So, looking at microservices at Confluence, the initial candidates are quite easy. Like you have platform services that can be reused by different teams, so it's quite easy to say, hey, you're going to replace those and replace them by a platform and say more products can use it. So we replace a scheduler, how we do attachments, and also how we do our operational transformation, which is kind of the engine that does collaborative editing, so you can edit your document at the same time. The other thing we did is we replaced the front end. So we got rid from the server, having it all packed together, but we replaced it by React. You should ask, hey, why React? And that's probably because of Angular or something like that. But the core and the hard part is in core functionality, and that's where we currently at. So we want to rip out a specific piece we hit a lot, and we want to replace it by a separate service. And that's hard to do as well, and that's probably a talk on its own. So that's about a little bit of the history of Confluence, and let's talk about 5 patterns I want to discuss today. I want to talk the basics, just go through it fairly quickly. I want to chat deployments, testing, security, and operations. And the reason why I want to discuss those is because when you start microservice, you have to have an answer on a lot of things, and you probably will make a wrong decision at some point. So if you want to get into microservices, you have to think hard, like, hey, how are we going to solve these problems I suddenly have I didn't have before? Let's start with the basics, and we go through them fairly quickly. Who in this room has heard of the 12-factor app? That's quite a few. I think the 12-factor app is a really good starting point, like, hey, how you should think about your service and what kind of characteristics it should have when you're building microservices. And this is one of my favorite quotes. It's not actually done as part of microservices initially, but it's a good way to look at it. You should treat them as cattle, not as pets. And what it actually means is they will be discardable. So when they start to misbehave, you shoot them and you get rid of them. You don't give them a number, you don't give them a name. So it's just not as a pet, but you give a name and they have a real identity. So if they start to misbehave, you replace it by a new one. And it sounds a bit harsh for the cattle, sorry for that, but it's a great analogy. So what's a minimal service? And minimally, it's basically you have three things, right? You want to expose a port, probably HTTP, but can be another transport. You want to have a health checks to see whether it's still behaving correctly. If it's not behaving correctly, you throw it out of the load balancer and you spin up a new one. That's kind of the whole kettle approach. And the last one, it's stateless. And I added a little asterisk in the stateless part because a service doesn't need to be necessarily stable. Sometimes you need state to keep it performant. One thing you should think of, like, a node can go down at any given time. So even if it contains state, another node should be able to take it over to make sure you can discard it at any time. It might be a bit of a performance hit, but you can build a state on another node if you need it. One other thing we find fairly useful is add a deep check. And a deep check is basically not as a health check. You basically say, what kind of dependencies do I have? Do I depend on the database? Do I depend on 3 other servers? And based on that, can I reach it? Is my configuration correct? Is my networking still working? You don't want to add it to your load balancer because then you get an interesting effect if suddenly 3 servers down something fails. But if you can add some monitoring and alerting to it so you get some insight how your environment is behaving. So this is a quick example. What it gives is just a simple JSON blob. You can make up any format you like. And you basically say, hey, this is going healthy and this is not healthy anymore. And you get a little bit more insight how your environment is behaving. Around code and builds, we try to keep them very simple. So instead of having a discussion around monorepo, it all depends on your situation, of course. But we just keep one repository and one build per service. Just most tools out of the box support that model, and it keeps things very simple. You don't have to do any fancy engineering to do so. And one of the interesting questions of the 12-factor app is, like it says, you have to have strict separation of config from code. And what did it actually mean? Because it's fine to put some config in your code, right? Probably not hard-coded, but everyone probably has some properties files in its code. And if you look at it, you have to think a little bit on how you deal with your config lifecycle. And we pretty much use the tools like Puppet and Chef. Any people using that in this room? Well, not too much, actually. I think the problem it creates, it has a lot of value, but the problem it creates a separate lifecycle. So suddenly you have to wait for your Puppet applies before you can actually push out your change. So you have to have some communication and potentially a hazard for an instance, so it slows you down. So what kind of lifecycle you typically have for configuration? First of all, you have configuration that's fine for a rebuild. It's probably a configuration that is coming across environments and you're happy to actually say, I'm going to rebuild the whole container or whatever your executable is, and it's fine. You can just leave it in your property file. The other part is like you want to do things only based on a redeploy because everything is discardable because we're not changing any things that's running, so we always need a redeploy. And you typically put it in environment variables. And we used to put it in our service descriptor, which I'll come to back to in a minute. And every redeploy, you change the configuration. That's kind of an exception on the rule because the 12-factor basically says you shouldn't change any active running configuration, always should trigger a redeploy. And that's not always true. I think you have 2 scenarios where you don't want it. One is, for example, you have feature flags, and you have a gradual rollout of your feature based on a certain percentage, and you slowly twitch the button to actually roll it out gradually. And the last one is operational flags. You want to kill a certain feature of your application because of an incident. You want to stop the system sending out emails, for example, because something went wrong. And that's slightly different. You probably want to have a different type of control on top of that. All right, let's talk deployments. And you have to realize, once you start to do microservices, you suddenly have to do heaps of deployments, right? It's not like something you do at the beginning. You actually do many of those, because you start with one service, but you end up with 10, 20, maybe even more, depends on your situation. So how are you going to deal with deployments? An interesting fact is we have a lot of platforms available. We have Google Cloud, we have Azure, we have Amazon, but they still require a lot of specific knowledge to get going, right? So how are you going to solve this issue? And you can choose many directions, but for me, if any of these things is true, then you have an issue. If you require a ticket and you probably need another team, and depends on the lead time of the team, you're probably going to struggle because it will take a long time to actually get your deployment going. If it's only one person in the team that can actually do deployment, then you're so dependent on that person, you will be waiting on that person all the time. And it's the bus factor as well. If that person is sick or on a wedding or whatever, you're stuck. And the last one, if it takes more than 50 minutes to actually deploy a service into production. And that's kind of like the litmus test for your deployment capability. How fast can you deploy something into your environment? So what we try to do as a good pattern is when we start a new service, we always push it into production, right? So you just create the empty shell, the port, the health check, and we get it all the way in production. So you don't have to worry about that piece anymore. It's there, it's up and running, and now the only thing you want to do is iterate as quickly as you can with your team to add the functionality you require to build. It gives a great opportunity actually already, if teams are dependent on you, to already start doing things and actually interact with your service, even if it's not complete. You can create an empty shell so you already have some sort of contract. So what kind of controls do you actually need? And there are quite a few you have to think about, because there are many things around deployments. First of all, and it's quite obvious, what is the runtime? What's the artifact you're actually deploying? Is it a Docker container, is it a WAR file, or is it something else? The other one is, what kind of compute does the service require? How much memory? How much CPU? How many nodes? It's all fairly important. Ownership is important as well, and it's important for two reasons. The first one that makes it really important is like when something goes wrong, you want to know what to do with that specific service. You have to know who to call. The other one is probably running a service in Amazon will cost you money, or any cloud platform. So you want to send a bill to someone or a department within your organization. Sometimes it doesn't matter because it's just one team looking after it, but at some point you will need it to see who is spending what on resources. The other one is, what kind of resources do you need? You have to define, do I need an RDS instance, for example? Do I need DynamoDB? Do I need queues? And you can go on for quite a while. Last two is actually you need something around alarms. You want to define your alarms like, hey, when should we start to wake up people, and when should we say, hey, something is misbehaving here? And the last one is actually already mentioned. It's configuration. You want to determine your configuration lifecycle. Probably not everything sits in a property file, but where do you set the configuration then? So what we kind of build is a small layer on top of Amazon. We pretty hardcore into Amazon, and we're not too interested in actually changing that behavior. So we leak Amazon information in the current contract just to get things up and running quickly. We don't want to spend too much time on building a whole abstraction layer. There are other companies doing it as a full-time business. And what you basically do as part of a YAML file, you basically say, hey, this is the binary. In this example, it's a Docker container, but it can be a standalone jar file as well. Depends on your needs. It says, here's the health check, here's the deep check, and just go and run it and run all the cloud formation that's required for this. The big advantage of this is that you don't, as a developer, you don't need to worry too much about Amazon. A lot is done for you by the platform. This is an example around how we define configuration. This is like where we say, hey, this is how we configure it, and you can override it per environment if you have different values there, which is quite powerful as well. And this is the last one, and it's more the resource section, right? So here we basically say we need an SQS queue, and we also need 7 instances of MX large tree. With that, we can basically define, this is the compute I need for my service, and we give the power to the developers instead of having to interact with a deployment team whatsoever. So while we have 500 servers in production, which is quite a lot, and that kind of shows like how easy it becomes if you have a platform, how easy it becomes for your development teams to actually think and be autonomous without having a big pool of people with specialized Amazon knowledge. You have to have them around, but it's not a mandatory thing anymore. The third thing is testing. There is quite a lot to do about testing, right? If you start to break up your monolith, testing becomes a lot harder. And testing microservices is actually quite interesting. So how are you going to solve that issue? Because if you think testing a monolith was hard, it's actually quite easy because everything is in one binary. You can spin it up and everything is there. You might require a database, but it's pretty much that's it, right? And if you tend to look at how we deal with testing, this is normally we draw a testing pyramid. And you have to realize whenever you have microservice, only your unit tests will continue to work. Your integration and UI tests will basically start to fail because you suddenly have dependencies and they might not be available. So the cheapest way of doing stuff is actually say, okay, whatever, I'm just going to point to a live service, maybe in a development environment, but that doesn't scale really, right? But if you have one dependency, it might work, but at some point, if you get 30, then it doesn't work at all anymore. So how are you going to trigger that? I think the answer to it is like using a mock service. And with a mock service, you basically spin something up, either in process or out of process, that basically mimics the behavior of the service you're depending on. However, it gives you a new problem as well. So let's first dive in the two options a little bit. If you do an in-process, you just spin up something based on your current application. If you use a Spring application, what we tend to do a lot, we use Spring profiles to actually spin up a different environment. Or if you do out of process, there are tools like WireMock or mock server where you can say, if this request comes in, this is the response I want to get. So here's a little example, fairly straightforward. You have a Spring Bean based. If you enable a different Spring profile, you just implement a stub. It's predefined behavior. If you want to go fancy, you can use a mock and specify the behavior as part of the test. It's pretty straightforward. However, if you do it as such, you miss the network element, right? Because normally you have some sort of transport, and it's pretty important that you actually say, hey, I want to bring in that network element for my testing. And if you have some sort of contracts, you can actually test them as well. We tend to use WireMock quite a bit. Mock server is fine as well, don't have a big preference. It's just what we use historically. And here you can define what the responses should be based on any request. This is basically creating a page, but you can define anything. But I think the big advantage is if you go against a live service, testing error states becomes really, really hard because normally the service behave well. So you have to build in specific error paths. With this, you can actually say, hey, if this request comes in, throw an error, you can actually start to test your error conditions quite easily as well, which is great. And it's probably something you want. However, the problem is with when you introduce mocks, you have a new problem. So you solved your test issue, but suddenly you have to think, hey, but how do I trust my mock? And I think there are roughly three solutions to the problem. First of all, you just say, I don't care too much. I'm just going to rely on monitoring, right? I've broken it down into smaller segments. I can redeploy fairly easily, so I'm just going to rely on monitoring. And it's acceptable for my customers if it breaks, because at some point it will break. So that's something that will happen. So what's your strategy there? Can you deploy and detect the error before your customers do? And if you don't, what's the behavior? Do you have some graceful degradation there? Second one is, if you already have a stable API, it should be fine. You probably already have some sort of CDK in place where you already verify whether your API is already in place, right? So if that's fine, you probably don't need to go any further. And that's largely when you expose APIs to vendors or whatsoever, then you should already have this in place. Last option is contract testing, and that's kind of the hip kid on the block if you talk about microservices. But they come at a cost as well. I think they're a great tool for collaborating with internal teams if you have fast-moving APIs, and it will detect a lot. So you create an environment with collaboration with different teams, but you incur the cost of adding multiple builds as well to make sure you actually detect a failure in your contract. So it's up to you. So I'm probably a big fan of having stable APIs, but I think contract testing is a good candidate as well. The last one we tend to do as well, to add a little bit more of security, so we're pretty sure we don't have any weird stuff to our customers. We have a semantic check, and what a semantic check basically means is we run a little automated smoke test before we put the service back in the load balancer. So the problem with a semantic check is that it's actually really late in the game. If this happens, I think all of your processes you have in place kind of failed. And you also want to limit the amount of tests you run over there because you don't want to rely on it too much. It's basically your core functionality you want to verify. For example, in Confluence, it will be create page or viewer page, maybe even. So that's the one thing you can do over there. But however, be aware, it's really late in the game. And you should limit it to a maximum amount of maybe 2 minutes to run, and maybe 5 tests. Otherwise, you will be into trouble. And you push more and more tests because it's easy, because you don't need all kinds of making up your dependencies. Problem number 4, security. So if you look at security, there are many, many standards around. So we have OpenID, we have OpenID Connect, we have OAuth 2, we even have one, but I don't think a lot of people are using it anymore. But if you look at those standards, they're all based on interacting with 2 services where there is a client involved. It's just exchanging your identity and a secret without giving your actual credentials to the third-party service. That's not what you want to do, right? But if you look at what's around, how do you secure a set of many services, right? You have many services running in your own environment, in your own data center. How do you deal with those? For example, you can trust your own networks. You guard it off, but that's quite a vulnerability as well. What if you have some server-side request forgery going on and suddenly all your endpoints are open? So that's probably something you don't want to do. So that's why we introduced ASAP, and very originally we call it the Atlassian Service Authentication Protocol. And it's a fairly straightforward protocol. So let's assume we have 2 servers. We have foo and we have bar. And we have a JSON Web Token in the middle. Who in this room is using JSON Web Tokens? Oh, quite a bunch, that's cool. And I think the nice thing about JSON Web Tokens is kind of an open standard where you can use a lot, but you can verify requests fairly easily. So what's inside the JWT for ASAP? And again, it's fairly straightforward. So the key important is like the key ID, which is the second one in the header. It basically says, hey, this is where you can find my public key. And the only thing you have to make sure that's available, you have a trusted public key server. Otherwise, you're starting to leak over them. People can forge requests anyways. The other one which is important is the issuer. It's the middle one in the body, where basically which service issued this request and who is the audience. So we know, hey, I'm going to call service bar, so that's what I put in the audience. The other one which is important, you probably have to carry identity across requests between services as well, so you have to have a strategy around it as well. And that's where we use the subject attribute for it. It's basically the global identifier of the user making the call, so you can carry the identity of the call through your service, so you know who is making the actual call. And what happens whenever foo sends a request, bar will look up the public key. Of course, it will cache it for a while and verify whether the request is valid. If so, it takes it for granted. All the other keys, I'm not going to explain it in too much detail. You can find it in the JSON Web Token spec. If you want to try it yourself, we open sourced it. So we're keen to get feedback on it, whether it's useful for your organization as well. We have libraries in Python, in Java, in Go, and in Node. So probably all the hipster languages are available as well. We have a Scala one as well, but it's not actively maintained. Okay, last one is operations. Little quiz, because it's the last one. People are starting to think about the next cup of coffee. So you have 100 kilo of potatoes. I dropped the potato word off. And they contain 99% of water. What happens if you dehydrate them to 98%? How much will they weigh? Any takers? At least one. It's 50 kilos. That's kind of a big difference, right? So what happens if you bring it into microservice land? What if you have a set of servers, they all have a single uptime of 4 nines, which is 4 minutes downtime a month. You suddenly go to 2 hours of downtime a month because of your failure rate will increase. That's why it's important to realize that failure is imminent in a distributed system, because if you introduce microservices, you will enter the world of distributed computing. And we all know that the 8 fallacies of distributed computing, they're still true, so you have to deal with that. So when we started, we actually thought like, hey, there are some things around to actually mitigate that problem, but we probably don't need them yet, but you probably will need them. And I think 3 things you really have to have in place. First of all, you want to have log aggregation. We have tools like Splunk, Logstash. There are many, many things available, but you have to have it in place. The second one is circuit breakers. And I think they became very popular by Netflix and with their OS Cloud libraries, but this is a really important thing because failure will happen. Last one is request tracing. You want to see if something fails, where did it fail, and where did the request came from. I think this is a screenshot from a situation around 3 years ago, and I was SSHing into 8 different nodes to actually figure out what the problem is. And that's pretty uncool. Your life will be very miserable if you're in a situation like that. So fast forward 3 years, we invested quite a lot in log aggregation, and it's part of the platform where we deploy as well. Now we can create nifty stats on how a system is behaving, and you definitely need one. So it's quite important to have something in place like that. This is just a random example, but if you can't create this instance in your system, your customers will ring you before you even know yourself. The other one is circuit breakers. And I think circuit breakers are important for 3 things, right? You want to know what your response time are for calling your different services. How much do you spend calling external service? Do you spend like only 20 millis, or do you spend like 300 millis and you're already ruining your own server response time for the client's request? The other one is back pressure. At some point, a subsystem will fail, so how do you respond? Do you have a strategy in place to actually relax the pressure on the system that's already in pain a little bit? And the last one, when back pressure doesn't help and you start to enter a failure mode, how do you respond? It's not something you should do as an afterthought. And for example, if you look at Histrix from Netflix, you always have to implement a fallback. So you have to think really hard on like, what should I do in an error situation? And it also gives you great insight again how your system behaves. So this is kind of a dashboard of one of our circuit breakers. I don't think you should use the free Histrix dashboard if you like, but it gives you great insight on how your system operates. And you can add alerting, and you can take action if some things are not right. Last one is request tracing. And if you look at request tracing, this is probably how your new world will look like. You have many servers, and you have many instances of those servers. So if they go back and forth, you have to think about, hey, how can I see how things are happening? And request tracing is a pretty simple protocol. You just add 2 headers to your request. You have a trace ID, you have a span ID. And for the second layer of services, you add the parent span ID, and you just increase the number of the span ID, etc., etc. So based on that, you can actually see what just happened, and you can actually see how this request is moving forward. And this is something we add in our logging. So we just send this out to a log system as well. So you see the last one is actually the trace ID. So if you get an error, or if you see a weird exception in your logs, you can actually figure out what is going on. Twitter released an interesting library. It's called Zipkin, with a nice UI as well. You can actually see, hey, what's going on. This is an example where we actually get some attachments. And you can see what the response times are, and you can drill down a little bit deeper. But that's kind of very helpful and insightful. Okay, this is the last one, and this is operations. And if you have a monolith, it's probably pretty hard to actually have an operations. You probably have an operations team, right, that actually is looking after your monolith. It's really hard to distribute it or get rid of the whole operations team. If you do microservices, you can still do the same and basically have one large team to look after microservices, but it's something you don't want. We kind of have the philosophy where you say you build it, you run it. So the team is responsible for running it, the team is responsible for the pager. And it gives it creates better results, right? Because suddenly a developer gets paged at 3 a.m. in the morning, and I'm pretty sure the team will work hard to make things better the next time because you don't want to have that happen. And when something happens, the team has really deep knowledge about the service as well, so the time to actually recover from an incident goes way down as well. So I think it enables us to create it through, if that's even a thing, through DevOps culture, a bit easy, because it's kind of like a smaller service area. Okay, it's time to wrap up. I think we discussed quite a lot of things. We discussed the basics, a few things you have to be aware of. We discussed you have to have an answer on how you do deployments. We discussed you have to have an answer on how you do security between services. We discussed testing and operational concerns, and that failure is imminent. But if I have only one thing you can take home after the session, is that it's all about that we deliver value as an engineering team. So even if you don't need all the things, as long as we deliver value in a sustainable way, then I think we're doing the right thing. That's it. Thank you. We have still 3 minutes for questions. Any questions? I have one question here. You're the experiment, so that's cool.
Right. You mentioned.
Oh, yeah, you should speak in the box. It's a bit weird, but that's how it works.
You mentioned 5 problems. How would you score them? Like, which one is the most challenging?
I think I tried to kind of like the basics, like it's said. I think the ones we struggled most with was like the last 3, having your operational concerns, right? So you have to have some platform in place. How do you deal with testing? Because it's really easy to say initially, we only have one service, just we spin it up, or we just rely on a real service. But at some point, you will have issues. But then if it's service number 7, then you have to revisit all the choices you've made. So, and the third one is deployment. I still remember a number of microservices started to grow, but we didn't have a great platform to actually deploy it. So we had one team that was doing all the CloudFormation work, but they're getting swamped with work because it took like almost 3 weeks to get the whole environment provisioned. So hence we started on a platform to eliminate that. So it grows a little bit. So I would start with testing because it's something you get issues with first, and also your operational insights. So do you have the log aggregation in place?
Perfect.
If you can.
Hi. You mentioned that you had over 100 or 500 microservices running in production. How do you get an overview of all these services?
Yeah.
What versions are running and dependencies and so?
So I think it's interesting because like if you look at 500 microservices, they're across different products. So not everyone needs to know of all of them. But the good thing of like a platform, like the deployment platform, we have a registry of all services. So and the ownership is defined in the service descriptor as well, so we can generate all the information we need based on the data we have in a service registry. So our deployment platform serves as a service registry as well, and we build a little UI on it, so you can actually search on which service, who's the owner, and who to contact. And it's really important. We have the notion of a service owner. So every service needs to have an owner. So if the person leaves the company or moves to a different team, then ownership will always be transferred. So. One more question? There's one behind you.
So regarding the you build it, you run it kind of thing, or basically the responsibilities between development and deployment. So obviously all of this have a huge stack of frameworks and so on. So is it a good practice to teach your engineers the whole stack on how to do stuff, or rather kind of have different responsibilities across development and operations?
And with stack, do you mean actually, like, for example, Amazon, or more like from a language or framework perspective?
No, I mean like on the operational level. So log aggregation, config management.
I think most of our engineers have a certain level of understanding of it, but we try to treat them as like a platform service. So you don't have to have deep knowledge. You have to know how to, for example, operate Splunk to actually get access to log files. You have to have some sort of basic understanding how Amazon works if you want to drill a little bit deeper. But in case, and that probably covers most of the instances, because most of the instances are around issues caused by change in the software. And if it's more a platform issue, then we know where to go through, and then we probably page the other team to actually jump in. So, because the amount of tools are so big, it's impossible to cover all of it. Do you have time for one more? No? Okay. That's it. If you have more questions, I'll be around. Feel free to buy me a beer later tonight. Thanks for dropping by. Thank you.